Jamb 2026 candidate, you are welcome to today's lecture, and today you can see what we are treating here. We don't enter organic chemistry like this, so I told you guys that we are going to complete this syllabus in the first week of March. Don't play! Don't play with me. Don't play with my expertise. Don't play with my track records. Don't play with my achievements. Don't play with who I tell you I am. Whatever I tell you I am, I am. Okay? So, if you want to act smart, you want to do your thing smart, because right now, if you prepare for Jamb UTME, you still read textbook, you are in error. Because this is not the time to be reading textbook. Jamb don't too near. You have less than 6 weeks left for this exam. You just have 43 days. 43 days to this exam. You still lose guard. Hey, so for those that are smart, if you need this short, concise lesson notes, okay, I have it in biology, I have it in chemistry, I have it in physics, I have it in English, okay. If you need this notes, very short, compressed to 300 slide, it's going to be very, very beneficial for last-minute preparation candidates. No time, those will be say time, no they their side again. But you will be say you don't read since. If you can't carry this note, read. It go to help your score, because the lectures here in this lesson notes, everything is tailored from Jamb syllabus. Only waiting Jamb wants make you know they enter the exam hall. 9 days inside my notes. So use my notes, use my notes, use my notes. No be today I started to prepare candidates for Jamb UTME. I've been preparing candidates for Jamb UTME for almost 9 years now. I only entered social media like 3 years ago, but I've been doing that for over 8 years now. So don't play with me. So if you need it, enter my DM, go to my profile. You are going to see my phone number there. Send me message. Tell me, say you need lesson notes, short, concise, simplified lesson notes, straight to the point. Plus the explanation though. Now the explanation you see so. Now when I do the explanation, now I do this video where you see so. So get it for yourself. Get it for yourself. Also get the sharp plan that will help you easily score 280 and above. You are going to do less and score more. At the end, even person when they read since November last year, you go score, you go pass them. That kind of thing can pay. Because the person don't get better strategy. The person you go there, they read data scatter. Do less and score more. Focus on, imbibe yourself into fat investments. Okay? Invest in the fat side. All the place where you say get fat mark. Invest for all those sides. Okay? Leave all these frivolities, frivolous investments. Stay away from frivolous investments and invest early. Our topic today is naming organic compounds. Alright? Naming organic compounds. That is what they call nomenclature. Alright? Nomenclature. IUPAC nomenclature. That's the International Union of Pure and Applied Chemistry. That's the meaning of IUPAC. Know the full meaning, that they set out for Jamb. Because what's the full meaning of IUPAC? International Union of Pure and Applied Chemistry. That's IUPAC. All right. Let's look at what we have here. Okay. So when we say naming organic compound, it comprises of, it's a general term that involves naming all the organic compounds. Okay. We never enter that 1,2-dibromoethane. 1,2-dibromoethane. No. We never enter that one yet. All right. We never enter that one yet. So waiting we did now, the general naming. We will soon enter that one very soon. All right. So, and I will settle down, teach them to you, teach you well, make you understand. All right. So this one we are looking at general naming. So the general formula and the name. What you get here down, the general formula. What you get here down, and the name. All right. The general formula of ALKANE. ALKANE. Take note of the what? The suffix. The suffix now, the last syllable. This ANE. ANE. What you end down? ANE. ALKANE. If you look this one now, ENE end down. ALKANEs. If you look this one now, YNE end down. ALKYNEs. Okay. All of them so now homologous series that they call them. This one is ALKANE as it is like this. This one will end with ANE. Anything ANE. Now one homologous family. Now homologous group that they call them. Okay. This one will be say end with ANE. Now for example, all the compound will end with this ANE that they call them. Say that belongs to the ALKANE homologous group. Okay. Then this ALKANE, this N, EN, ALKANE. Okay, this one another homologous group. Anybody will be say end with EN. Any member will end with EN. Belong to this ALKANE homologous group. Why this YEN? That's this INE suffix. Okay, any member will belong to this INE, belongs to the ALKYNE homologous group. So what's in the homologous group? Homologous group now, group will be say all the members for that group, they different from one another with just CH2. That's 1 carbon atom, 2 hydrogen atoms. Now be waiting each of the member they different from one another. So for example, I be number 2. Waiting differentiates me from number 1. Now because see, I get 1 additional carbon atom and 2 additional hydrogen atom. That's CH2 alkyl group. Okay, CH2 alkyl group. So the number 2 can start from 18. Okay, the number 2 starts from 18. This second one, this ALKANE, the second member for the second homologous family. The second homologous group starts from waiting 18 and 18. 8, I tell you say now 2. In it shows say it comes from this homologous family ALKANE. All right. So that's that for that. So you get 18, you get propane, and so on and so forth. So since we know 18 now, say 18 now 1 atom of carbon and 4 atom of hydrogen. If we want to calculate for propane now, we will come add this one, join here. Okay, we'll bring this one, substitute and into here, they get the rest. We go use propane, oh, they get butane. If you put this one now, we'll say 1 get propane now. You carry this 18 now, put for here, will come be CN3. We don't already know say now prop. How we want to know how many hydrogen atom they here now? because say na prop, we go put CN3. How we take know how many hydrogen atom dey? Na through this formula. We go do 2 times N. Okay, wetin be N? N na 3. 2 times 3 will be 6. That's now 6 hydrogen atoms. 9 dey this propane. As easy as that. Now you go still do this alkyne own. So example of alkyne, ethane, propane, and so on and so forth. Just know say this prefix na the amount of carbon atom wey dey. And I want to make you know one thing about this homologous series. How to identify them. The first one wey dey here will be alkane, ANE. Now anybody wey dey this homologous series, they carry only single bond, single carbon bond. All right, single what? Carbon to carbon bond. All right. While the second one, these alkanes, this one, they do wetin? They carry double bond, okay, double carbon to carbon bond. While the third one here will be this alkyne, they carry triple wetin? Carbon to carbon bond. So this alkyne gets the highest concentration of carbon. This alkane gets the second highest concentration of carbon, while this alkane gets the lowest concentration of carbon. Let's look at the rules governing IUPAC nomenclature. That's naming of organic compounds. Okay, like this 1,2-dibromo, 1,2-chloro, 1,2-dibromo-ethane, 1,2-dibromo-diene, 1,2-dibromo, and so on and so forth. So maybe we learn the rules. Okay, ensure you are jotting down. The first rule is that name the longest carbon chain, and that longest carbon chain is equal to the parent name. The longest carbon chain, straight chain like this, the longest chain, just name am 1, 2, 3. You count am 1, 2, 3. If na 3, for example, you go name am wetin be that prefix why I tell you say stands for 3. Pro, you know say na pro, it go be prop, now it go be prop. If you be say na 4, you count 1, 2, 3, 4. The longest carbon chain, you can't count 1, 2, 3, 4. I go teach this thing again, but I'm just explaining the rule to you. If you be say na 4, you can't count. Okay, what you go name am? What be the prefix for 4? Boot. If you be say na 1, you count. What be the prefix for 1? Earth, and so on and so forth. So that's that for that. That's the parent name. So you start numbering from the nearest functional group / double bond. You start numbering from what? The nearest functional group / double bond. The nearest functional group will be there / double bond. What is the functional group? Functional group na group identification for people wey be say, people wey be say dey one particular group. That group, wetin make them dey that group now because say all of them they do the same thing. They get the same chemical property. So they can't get one symbol where they know them. Okay, they get one particular symbol where they know them. If you see that, you say, if you see that symbol, it won't be like tribal mark. If you just see that tribal mark like this, you just say, this person na Hausa person, this person na Urobo person, this person na Igbo person, this person na Yoruba person, and so on and so forth. So just like that, just take functional group as tribal mark where you take identify so tribe, so group of of people because of say that particular family members they possess one kind of chemical property. The same kind of property, they get the same style. It just be like the way Hausa people they behave the same way, the way Igbo people they behave the same way, the way Yoruba people they behave the same way. Now that functional group they determine am. And just take that functional group as tribal mark. I will show you for the subsequent slide how functional group they look. But if you want to start with the number from the nearest functional group. Start from the nearest functional group. The side where you see a functional group near pass, or the shortest chain where it branch, or the shortest chain where it branch. Then preface, which is what starting. I already explained this one before. For waiting, substituents. All this one are substituents. Use preface for all the substituents, such as chloro, nitro. Now this one you can't name next. You don't already know the parent's name. By counting the longest straight chain carbon. Okay, you don't know the parent's name. Then the next thing is to add the preface of substituents. If substituents dey like methyl or chloro or bromo or nitro and so on, iodo, there are many fluoro, there are many. So all those substituents are like names they not be fully part of organic chemistry. Okay, like this chloro now inorganic chemistry, this nitro now inorganic chemistry, bromo inorganic chemistry, iodo inorganic chemistry, and so on and so forth. Then after you don't do preface finish, you can do suffix, okay, which is the ending. Okay, for functional group you can put the ending. Now this suffix go end up. Okay, this substituents go start am, the naming. Then this parent name go dey the middle. Okay, for example, functional group such as all, now their tribal mark be this. Now the end am, all this thing now the end am. Now the tribal mark be this for all the functional group. Own, all this one are the name, the same name where they give them. You'll be like the name of the tribe of the functional group. You'll be like Hausa. Okay, Hausa, sa. Everybody, Hausa must be their name. You understand? So all, own. Don't be one be this one. Now own. Oic, that's carboxylic acid. Oic. Okay, and so on and so forth. They get many functional groups. I will teach you everything. Then when you don't name and finish, you can do some consideration. When mixed, name inorganic before organic. That's make you name all these ones first. All this inorganic before you name organic. Okay, now I be waiting they give you for this preface. Okay, name in alphabetical order, like all these substituents. For example, if you want to name them, maybe you get more than one substituent for them. You get chloro, you still get nitro, or you get chloro, you get bromo. Name them alphabetical order. If chloro and bromo dey, which one you first name? You first name bromo before chloro. All right. That's the simple rule for what naming organic compound. So master them, and I will teach you how to name organic compound very soon. Now let's look at the structure and tetravalency nature of carbon. So carbon has 4 valence electrons, and this 4 valence electron enable it to form 4 covalent bonds. All right, 4 covalent what? Bonds. If you look at the periodic table, on the left side of the periodic table, you have what there? You have metals. On the right side of the periodic table, you have what? You have non-metals, mostly non-metals. Then in the middle of the periodic table, in between them, you have carbon there. So carbon is like an intermediary in the periodic table. It neither donates or accepts electron. Rather, it shares electrons with these non-metals and this metal. You understand? So you can see the tetravalence nature of carbon sharing electron, okay, through covalent bond, okay. This tetravalency nature of carbon, which enables it to what? To form 4 covalent bonds, allows it to catenate, what they call catenation, catenation of carbon, formation of chain or formation of long chain and also branching. That's anything concerning chain, formation of chain is catenation of carbon. All right, that's it. So it is because of this tetravalency of carbon, because it is able to form 4 covalent bonds, because it has 4 valence electrons. That's why it's able to what? To form chains and also branching. So this is the basics for millions of organic compounds you know today. This tetravalency of carbon and the ability to catenate. Okay, that's that for that. Now let's look at the classification of organic compounds by functional group. Okay, I already taught you what functional group is. I know they give us a long definition. I will explain the concept of functional group to you again. Functional group is like we have a family, and the name of the family now Hausa. Everybody for that family, Hausa must be a name. Your name is Toby, right? Toby Hausa. Your name is Usman Hausa. Your name is Muhammad Hausa. So that Hausa must be your name. For example, I'm explaining what functional group is to you. So that tribe, that Hausa way that they add to their name, now waiting we they identify them. So anybody name when you just see whether Hausa and end up, just know say this person are from the waiting from this particular functional group called Hausa. And waiting make there be Hausa because all of them get one particular style of doing things, which is called chemical property. They get one particular style of doing things. They get the same chemical property. Now make they call them Hausa. But for their name, you go to see that Hausa then go end up Usman Hausa, Muhammad Hausa, Ahmed Hausa, Aisha Hausa. You understand? So that's functional group. That's what I just explained. So each member of the group possess the same words, chemical property. Okay, the same chemical property, and their name they end with waiting a particular suffix. Okay, which is that Hausa I explained. Now let's look at the classification by functional group. The first most common functional group we have is alcohol. Alcohol. Nothing concern us concern the what it concern us now this OH. Okay, OH and this all. OH and this all. Okay, this OH be like their tribal mark. Anywhere you see them, that OH must be their face. Is the tribal mark. That tells you that it is the what? It is the alcohol family. And this OL we end up oil. This oil. Now the waiting the Hausa where they did all their names. Hausa. So you can get ethanol, methanol, butanol. All of them are all that Hausa where I explained to you just now. Ahmed Hausa, Umar Hausa, all these things, he must be. Now you go tell them say, oh, this person now from the alcohol family. This person now from the ALKANE family. Remember, not the only alcohol that they call it. You can also call it alkanol or alcohol family. Alright. Another one we'll get for you now, aldehyde. Aldehyde. And this aldehyde now CHO. Now be waiting with their tribal mark. Aldehyde can also be called what? Ethanol. The ethanol family. And now R, now end up. All of them they carry R. Now that R be the Hausa. See another one, ketone, also called the alkanone. Okay, on. Alkanone. Now C, then double bond to O. Cr on CHO. CHO, that's C go bond up. OH go bond down. Okay, that's for waiting for aldehyde or alkanol. This one alkanol, you must see double bond for alkanone. Okay, that's ONE. All right. So we also have carboxylic acid. The acids COOH. That's it ends with the oic. Now that oic can be the Hausa OIC. Okay, now be the Hausa. Then this COOH now their tribal mark. So when you see their structure, for example, or their formula, you can see COOH. You say, oh, this person are from carboxylic family, now from carboxylic acid group. See another one again, amine. We get many. We go look at yours now. Amine. And this amine, now waiting. NH2. Now they end up. This one, then be their tribal mark. Then this iron, they get ido, they get amine. Constantly get amine. Okay. So this iron here, now waiting. Now that they are the surface of their name. What they call them? You'll be like their surname. Hausa. Okay. Their surname, then be this iron. Then this one, so NH2. Now their tribal mark. So functional group determines the chemical property such as alcohols. They form what? Hydrogen bonds. And they are what? They are soluble in water, and so on and so forth. Now, let's look at the whole functional group. See the functional group here. All the functional groups we Jamb want make you know. Now, then they here so. Alright? Now, all the functional groups we Jamb want make you know. Then they here so. Then they textbook. Alright? So, the first one we'll get for here now, alkanes. This arrow here, it stands for alkyl group. Okay? This arrow so stands for what? Alkyl group. So, it's when alkane is when an alkyl group is bonded to what? CH3. Here now, alkyl group. Depending on the alkyl group, the particular alkyl group. So the next now, alkenes. I already explained all this thing for you. Now double bond. This arrow stands for alkyl group. You see, and CH double bond, 1,1H. Okay. Then this one, so where they here, this arrow stands for the waiting, the alkyl group bonded to this what? This C. Depending on the alkyl group, we bond go there. Then this alkyne. Okay. They say this arrow stands for alkyl group, triple bond. And this alkyl group where they here, waiting suppose they there, don't be hydrogen for this arrow. Yes. Then see another one, alcohol, OH. This one, so this OH now their tribal mark. This all. Now their surname. Okay. Then you have the aldehyde. This is the functional group of aldehyde, CHO. And aldehyde are also called ALKANE. Okay. Ending with what? Ending in al. ALKANE. Okay. Al stands for what? Alkyl group. Alright. We also have ketones or alkanones, which is what? Just CO. Okay. With double bond. Okay. Double bond. The day alkano CO. I will show you the diagram. No worry. Calm down. We have carboxylic acid, COOH, which is oic. Arrow COO. You want to be like an incomplete carboxylic acid. Okay. When a carboxylic acid lost one H, you will get ester. Okay. Then see the amine. One alkyl group bonded to it. Depending on the alkyl group, bonding to it, bonding to NH2. Okay. Amine. Then see amine. Why I tell you just now? Alkyl group bonded to it. CO. Then waiting. NH2. This amine they carry double bond. Okay. Amine they carry double bond. You get nitrile. Alkyl group bonded to C triple bond nitrogen. Okay. You get thiol. Okay. Which is alkyl group bonded to S and hydrogen. Then you get halogen alkane, which is alkyl group bonded to S, which is S can either be chlorine, bromine, or iodine, depending on the halogen inside of them. Okay, so it's just anything halogen alkane is just alkyl group bonded to halogen. Now let's look at the empirical and molecular formula. I'm going to teach you how to calculate empirical and molecular formula. We'll start treating calculations in chemistry next 2 weeks. All right. So empirical formula is the simplest ratio of atoms. The simplest ratio of atoms. For glucose, for example, you have CH2O. That tells you that in glucose, the ratio of carbon to hydrogen to oxygen is 1:2:1. All right. So molecular formula is the actual number of atoms. That's the actual number of atoms. Remember, empirical formula is the simplest ratio of atoms. Molecular formula is the actual number of atoms. Okay. There are ways to calculate molecular formula and also to calculate empirical formula. All right. Jamb the set questions from here where we are going to teach you. For example, this glucose we have here. C6H12O6. This is the actual formula or the actual number of atoms, okay, that it contains. It's derived from the percentage composition and molar mass. So you divide by molar mass, the particular percentage of composition in grams, you divide by molar mass, then you divide by the smallest to get your molecular formula. Isomerism. What is isomerism? Isomerism is an organic phenomenon whereby organic compounds appears to have different structural formula but the same molecular formula. It has what? The same molecular formula but different structural formula. One molecular formula, for example, ethane, but ethane does not have isomer. Let's start with where you find isomer, okay? Let's say butane, okay? Butane, okay? The isomer of butane. The molecular formula of butane continues to be what? C4H10. But it has different structural formula. And those different structural formula that it has are called isomers, okay? So butane can have up to 5 isomers. It's still the name butane, it still remains butane. It's still called butane with the molecular formula C4H10, but it has different structural formulas. That is isomerism. And a subject or a compound that exhibits isomerism is called isomer. So butane can have 5 isomers. That's 5 different structures, but it still retains the same molecular formula. That's isomerism. And we have different types of isomerism, but the one that is suggested by Jamb that you study, Jamb say make you know that one. Now these 3 isomers we did here, okay? We have the structural isomer, we have the geometric isomer, and we have the optical isomers, okay? So we also have positional isomer, but all those ones, Jamb no say Jamb no ask us that one. Now what Jamb say make we do, now we do, all right? So now that one make we teach you. So if you can't say you want to go to study all those ones, you can go and do that, all right? My own is to prepare you for this exam. For you to pass this exam, you score high, you come and bring my gratification. All right, let's look at structural isomer, okay? Structural isomer is the easiest. The same formula, different connectivity, such as butane versus isobutane. The same formula, but different connectivity. The way the carbon and hydrogen bond is connected is different, a little bit different. All right, so that's it. You have a little bit difference in the connectivity, but the same formula. Okay, the same structural formula. Okay, it has the same structural formula, but the connectivity, the way it's connected, is just small slight change, just this, such as butane and isobutane. Okay, so now the same structure, now butane and isobutane get, but the arrangement they a little bit, the way that they connect them, they a little bit different. Okay, then we have geometrical isomers. What is geometry? Let me ask you. Is geometry not angles? Angles and dimension. That's geometry. So when you are talking about geometrical isomers, you are talking about the cis and the trans chain. For example, the cis and the trans chain in ALKANE. Okay, the cis and the trans chain in ALKANE. What does cis and trans chain mean? Cis chain, okay, is straight chain. Maybe you will have chlorine here and you have chlorine here. Okay, chlorine here, chlorine here. But trans chain, I will teach you all these things so later. Trans chain, I will show you the work when I'm solving. Okay, trans chain is when you will now have chlorine here, you will now have another atom here, maybe hydrogen here. Down here, you now have chlorine here again. You will now have hydrogen here. It's mixed. Okay, cis chain is how you have only chlorine or hydrogen up. Then you have only chlorine or hydrogen down. Okay, that's cis chain. But in trans chain, then they transfer them, then they transchange them. You will now have chlorine and hydrogen up. You will now have hydrogen and chlorine down. Trans is a geometric isomer. The angle, different angle. Okay, so let's look at the optical isomers. Okay, optical isomer is the mirror image, which is the chiral carbon. Just know the definition. Jamb, they hardly said anything from optical isomer apart from the definition. Okay, so it's a mirror image chiral carbon. Just know say that mirror something involving mirror is optical. You know what it be optical now. So isomerism explains the diversity of organic compounds, the same chemical formula, but different structural formulas. As simple as A, B, C, D. I will see you guys in the next class.